Good afternoon, calculus students. So Mr. Chen again. So today I would like to talk about sequences in series for Unit 9, 9.1 for the first half of 9.1. So a sequence is a list of numbers in a given order. Okay, so this one you want to fill in the blank. So a list of numbers. In mathematics, a sequence is a list of numbers whose domain is a set of real numbers. It's a list of numbers. So for example, like this one, a sub 1 for the first term, a sub 2 the second term, a sub 3 the third term, and then a sub n to the nth term. So for the set of a sub n, if you see the braces, that means the set. So that equals negative 1 to the power of n times cosine of pi. So the terms are, well, depending on the situation, if you started with n equals 1, so if you started with n equals 1, so that means it's negative 1 times cosine of pi, it's always negative 1. So which is 1. So this one is like an alternating sequence. So it's like 1, negative 1, and then 1, negative 1. And depending on where you want to start with n, so this one, if you started with n equals 1, so that order would be like this. If you started with n equals 0, then that would be considered 1, negative 1, negative 1, positive 1, negative 1, positive 1. Okay, so depending on the value of n that you started with. So like this one here, so b sub n. So let's say that you started with n equals 0. Okay, so this one is or, so you can give out to order. So let's say that b sub 0, so 0 divided by whatever that is, so it's always 0. So let's say that you start with n equals 0, so 0. And then n equals 1, so this one turns out to be 3 over 2. And then n equals 2, so that the top would be 6, denominator would be 3, then that would be 2. Okay, so start with n equals 0, n equals 1, and then n equals 2. Or if you start with n equals 1, then that's just like 3/2, 2, and then n equals 3, so 9 over 4, like that. So a recursive series is not defined by an order. Instead, one term is given and the root is given that describe the next term in the term of the previous term. So given that a sub 1 is 4, a sub n plus 1 equals 3 times a sub n minus 2. Whatever the preceding term that you have, you need to put it as part of the factor, and then you want to calculate the next term. For example, like this one, a sub 1 is 4, so a sub 2 would be 3 times a sub 1 minus 2, then that would be 3 times 4 minus 2, which is 6. And then a sub 3, so 3 times a sub 2, so 6 minus 2, so 4 times 3, 12. And then a sub 4, so 3 times a sub 3, 12 minus 2, 10 times 3, 30, like that. So those terms, so that would be considered 4, 6, 12, and 30 using the recursive formula. And then the other one, consider that a sub n, the set of a sub n, is given as 1 over 3 to the power of n. So the terms are 1/3, 1 over 9, 1 over 27. If you start with n equals 1, 1 over 81. So this one, so you can see by inspection that n goes to infinity, a sub n goes to 0. Well, because that the order is, the number is getting smaller and smaller, eventually it's getting close to 0. So here's the theorem that you need to know on the limit of sequence. So let f be the functions of a real variable such that limit of f of x as x approaches infinity, so that equals L. If the set of a sub n is a sequence that such that fn equals a sub n for every positive integer, and then n, then limit of a sub n, n goes to infinity, equals L. So what this means is that if n goes to infinity, so that the limit exists. So it's going to be considered a defined number. So that means, so we can say that the sequence will be considered converges. Okay, so if the limit of sequence exists, then the sequence converges to L. If the limit of sequence does not exist, then the sequence diverges. So check it out, some of the example here. So a sub n, so this one is 3 plus negative 1 to the power of n. Anytime they see things like that, negative 1 to the power of n, it's called the alternating sequence. So depending on the value of n, if n it's an even number, so that means this one is always considered 1. So 3 plus 1, it's always what? 4. Okay? So if n is even, so that means the number it's going to be considered 4 right there. But what about if n is odd? If n is odd, this number is going to become negative 1. So 3 plus negative 1, then that'll be positive 2. So 4 and 2, so depending on which one that you go. So limit as n goes to infinity. So if n is even, so that means it's going to be 4. But the thing is that if limit as n goes to infinity, but this time n is odd, then the limit will be 2. Inconsistent limit, so this one the limit does not exist. So if the limit does not exist, so therefore the sequence would be considered, the sequence just considered divergent. Okay, so the sequence diverges. So therefore the sequence of a sub n diverges. Well, because that the limit does not exist. But what about this one here? So b sub n, the set of b sub n equals the set of n over 1 minus 2n. Okay, so take the limit as n approaches infinity. So the way to find out the limit, so we take out the n behavior, or using the L'Hopital's rule, because this one is like infinity over negative infinity. So it's kind of like an indeterminate form. So take the derivative, top and the bottom. So we got 1 over negative 2. So negative 1 half. So the limit exists. So therefore, the sequence of b sub n converges. So this one is pretty easy to do. Just find out the limit. And here's some of the facts that you guys need to review a little bit. So before you start with the homework tonight, so make sure that you guys check this, some of the review problem that we did from example, not the example, but for the algebra 2 factorial. So n factorial, just like n times n minus 1, n minus 2, n minus 3. So for those you might be wondering, why are we doing this? Because this one is linking to the second half of the video, 9.1b. So 0 factorial, it's always 1. And then 2n factorial, it's like 2n times 2n minus 1, 2n minus 2, 2n minus 3, and so on and so forth, all the way to 1 right there. And then 2n quantity factorial. Oh, you know what? For that 2n factorial, I think I did it wrong. Because 2, that's a coefficient. Okay, so this one, gotta be very careful with the parentheses, without the parentheses. So the 2n factorial just like 2 times n factorial. So that would be n times n minus 1, n minus 2, n minus 3, blah blah blah, to 1. So 2 times this whole product, n factorial. If that's 2n quantity factorial, then that would be 2n times 2n minus 1, 2n minus 2, and then 2n minus 3, and then all the way down to 1. Okay, so this one is some of the example that you guys can do. A factorial, so it's like a, pick 6, for that the permutation. So this one can be written as a times 7 times 6 factorial over 6 factorial. So the 6 factorial got cancelled. So a times 7, 56. 5 factorial over 3 factorial, so it's 5 times 4 times 3 factorial over 3 factorial. So the 3 factorial got cancelled, so it's 20. Okay, so this one is just the part 1 of sections 9.1 of Calculus BC video. So it's about sequences and series regarding using the basic limit test to find out whether the sequence converges or diverges. So thank you for watching the video today. So I'll see you guys next time. Take care.